Okay, here we go. This particular homework, rarely do I ever use class exercises. I'm just choosing one of them to do. So do class exercise number 10 and then written exercises 1 through 14 all. That should make sense. If not, send me an email. Yeah, proving or proofs do not end. We'll be doing this for the rest of the year. We're going to get a couple theorems today. Theorems 2.1 and 2.2. And proofs will be the most challenging thing we do this entire year. All new material in geometry, unless it's a definition or a property, will be proved, or a postulate, I should say that as well too. So we need practice. Let's get some practice and doing some proofs. All right, so here we go. What do we got here? Well, we got a segment and we have a midpoint. M is the midpoint. They love using the letter M to represent midpoint, but don't always assume if you see the letter M, it means midpoint. Well, somehow we're going to get to a formula, two formulas, in fact. All right, so that's our starting point, and this is our ending point. So let's see what we got. What do we got? Well, if we think about where we're going to a statement about a segment length, AM and MB. So we should probably have some statement that involves AM and MB. And if I look at that, well, we got our classic segment addition postulate, which states that AM plus MB equals the whole darn thing. That sounds like a good place to start. Let's see, what else do we have? Well, if we look at that given, it says M is the midpoint, and we think about what does that actually mean? Let's see, if M is the midpoint, what are the consequences of being a midpoint of a segment? Pause the video and think that one through. So let's see, if M is the midpoint of a segment, I can think of two consequences. First off, a midpoint breaks things into two equal parts. So I can make the statement AM is equal to MB. That's a true statement. Um, And the second consequence, well, I'll go ahead and make that statement right there. That's the definition of a midpoint. So if you, the second statement is somehow we can get to some equation about it being midpoint. Like we can state its mathematical relationship. If you're in the middle, then you should be able to say something mathematical, and that's kind of the point we're going to try to address right here. So a consequence of being a midpoint is you make two equal parts, the left side and the right side. And that's what I just stated right there. And the reason is, well, that's the definition of a midpoint. Okay. What else can I do right now? Well, let's see, I could take this statement now right here and I could do some substitution. Let's see, if I see the letter MB, I can write AM. And look, right here I see the letter MB, so I could write AM. Or if I see the letter AM, I can write MB, and I see that one right here. So I can make two different statements using that, just doing a quick substitution. So if I did that quick substitution, and the reason why I know I need to do that is because down there, that's what it kind of says right there. So I'm going to take that statement in red and do two substitutions. First, I'll substitute for MB, write AM, and then I'll put a semicolon and make another statement. Do you see what I did? Now, once again, how did I know to do this? Well, I knew to do this because I'm looking down at the bottom, and the bottom, it says a half. And the only way I'm going to get a half is if I divide both sides by 2. And so I need something with a 2 in it. And notice now, if I do a little bit of simplification or combine like terms, AM plus AM is 2AM, and MB plus MB is 2MB. And that's how I'm going to get that half, is because now that's combine like terms or simplify. This would not be addition property because I'm not adding the same thing to both sides. Okay, so now if I divide both sides by 2, that is the division property. I get to that statement right there. Okay. And we've now arrived at our first theorem of chapter 2. So you need to write this down in your book of truth. So let's see, theorem 2.1 is called the midpoint theorem. So you can either say theorem 2.1 or midpoint theorem. And it simply says that if you have a midpoint of a segment, that you get that equation right there. And technically it's two equations. That the left piece is equal to half of the entire piece, or the right piece is equal to half of the entire piece. And for those that don't like fractions, well, if we multiply both sides by 2, we would get to that statement. So let's see. The first statement says that either one of the two pieces if you have a midpoint is equal to half of the whole. And the second statement there in blue states that if you take either one of the two pieces that you make and you double it, you get to the whole. So it isn't a different equation in the sense of it's talking about something else. It's still talking about the two pieces, a piece of the whole and the whole. It's just one is dealing with a half and one deals with two. And you can use either one. All right, so pause the video, make sure you write that one down. Okay, and if this applies to segments, then it probably should also apply to angles. Now, we don't have a midpoint of an angle, but we do have an angle bisector. So let's see, BX is an angle bisector of ABC. In other words, it cuts it in half. We're not going to prove this one because this proof would be exactly the same as the previous one. We could make the angle addition postulate, then we could do some substitution, combine like terms and divide by two, and we would get to the same thing. So make sure you're going to need to pause the video and write this all down. Okay, so you got this written in your book of truth. This is the second one, and I'll just say, remember I made the statement, we're going to prove all theorems. We'll prove all theorems that are unique, and this theorem is, the proof is exactly the same as the previous one. And if you're curious and you actually want to see the proof, it's written in the book. You can look it over, but I will not be proving this one. All right. In many geometry books, like when you're doing homework and whatnot, you get stuck and you don't know where to go, right? And this is not a theorem. I want you to write this down, but I'll call it my theorem. And my theorem is that when you're doing homework and you get stuck, you should probably think about what happened in that section because they probably want you to use those techniques that they taught you in that section. So, what skills did we learn today? We learned something about a midpoint of a segment. We got those formulas. And then we learned something about an angle bisector, and we got similar formulas. So tonight, when you're doing your homework and you're kind of stuck and you're wondering, what do they want me to do? Well, they probably want you to use one of these two theorems that we learned about today, 2.1 or 2.2. All right, so what does homework look like? Well, it's going to give you either angles or it's going to give you segments. If it gives you angles, there's going to be angle bisectors involved. So if you look at these questions right here, these are classroom exercises. Remember, I gave you number 10. But for instance, there's the word bisector, bisector. If they talk about midpoints, then they'll use the word midpoints. And the cool thing is that in both cases, the idea is fairly similar. So I'll just pick one. Let's see, I'll pick number 4 to do real quick. So it says E is the midpoint. So that means E right here is the midpoint of AF. So the entire thing AF. Then it says that AE is congruent to EF, and it says what postulate definition or theorem justifies the statement. So 2.1 says that if you are the midpoint E of a segment, then you make two equal parts, which means this part, tick mark, is equal to this part right here, right? It also says that the smaller piece is equal to half of the whole, or if I double the small piece, I get to the whole piece. So what justifies that that piece is equal to the other piece? It's the consequence of theorem 2.1, so theorem 2.1. All right, so that's what homework is going to look like to ask you to this. I'm going to show you this one. Everybody always misses this. Believe this is number, or this is similar to number 10 on the written exercises. And it says, write the number that is paired with the bisector of angle CDE. So let's see, angle CDE, well, that's the only angle that they show there, the large one, and the bisector is the blue portion. So it says write the number that should replace this question mark right there. All right, so let's see if we can figure this one out. Well, just by observation, right? This is a nice easy one. You should immediately say the answer is 60, right? Kind of looks like it's 60, right? I'm going to show you mathematically how you figure this out if it's not obvious. The number 10 one is not that obvious. So let's see how we can figure this one out. Well, we know postulate 3, which talks about the angles and the fact that you can make a protractor. And it says that if you want to find the measurement of a specific ray right here, what number is paired with this, you take the other two numbers, 80 and 40, and you subtract those two numbers. So if I do 80 minus 40, right, I get to, let's see, I get to 40, right? So let's see, I get to 40. 80 minus 40 is 40. So that means from here to here is 40 degrees, right? But what does it mean to be a bisector? Well, a bisector would cut that 40 in half, which would mean that it would leave 20 degrees here and 20 degrees here. So blue is not 20 degrees, right? Blue is the number that's 20 higher than 40 or 20 fewer than 80. If that didn't make sense, rewind, play that one again. So yes, the answer in fact is 60. I think that most of you could have just looked at that picture and guessed, but I'll say number 10, it's not an obvious number. You'll have to do the math that I just did. So once again, I'll do this real quick. To find blue, because it's an angle bisector, we subtract 80 minus 40. That's 40. Since 40 goes from C all the way over to E, 40 degrees, then we would need to take half because blue is an angle bisector. Half of 40 is 20. And if we add 20 to 40, because notice the numbers are going in an upward direction from right to left, 40 plus 20 is 60 degrees. And there you go. Okay. On number 13 on the written exercises, there's going to be coordinates on a number line. Remember, if you're trying to find the distance between any two of them, it's the same thing as with the angles right there. You subtract the coordinates, take the absolute value. If you get a negative number, remember the answer must be positive. So if the distance between any 2 points is 10 and it's asking something about the midpoint, 10 divided by 2 is 5. Add or subtract 5 from the two endpoints of the segment to find the coordinates. So if you can just imagine that as a similar procedure as what we did with the angles, you should be good. You will not be taking quizzes, so don't worry about that. Or Brandon, if you're watching this, you will be taking a quiz. So your quiz is going to be, I'll give you a conjecture. You're going to have to be able to identify a hypothesis and conclusion. You need to be able to write a converse statement from a conjecture. You got to be able to prove something is false. Remember, you just need to provide one counterexample. And then you need to be able to do the segment addition postulate or the angle addition postulate. And that means I'll give you some values. You just simply need to, just like you did for homework, apply the angle addition postulate and the segment addition postulate. And that's it for today. I will see you in the next class.